from the video from last time. So what's the next perfect square? No. Next one. Next one. Okay, this is through 20 squared. Excuse me. I don't see any reason to talk. You guys turn that light off for me over there, Joe. Okay. Here I've got these all the way down to there. Basically, when you simplify a square root, you're simplifying square root of x. I am asking what number could I square, or we'll say multiply by itself and get x as the answer. That's the question it's asking you. It is an operation just like multiplication or anything else. Multiplication says if you have 5 3s, how many do you have? You have 15, right? This is asking you, what number could I multiply by itself or square and get the number under the square root as the answer? Most of the time, you will not be able to answer this question. Does anybody know why? If you look at those numbers to the left, between the numbers 1 and 400, how many times can I answer that question? 20 times. Now, of course, there's more perfect squares down. They go on forever and ever. I just did through 20 squared. So that's the thing. It's not cutting it in half. It's what number could I square or multiply by itself and get that number as an answer. The only time you can answer that question is here. Here, here, here. These are for the numbers 1 through 400. These are the only numbers that you can answer that question accurately, as far as integers are concerned. A lot of the time, let's put there's 20 numbers here. How many integers can you not answer between 1 and 400? There's 20 here that you can't answer. So if
All the rest.
well, how many is that? So out of 400 numbers, 20 of them you can answer the question. 380 of them you can't. So I think that qualifies most of the time you can't answer the question. Agreed? Because you can't answer the question, what is the square root of 25? The answer to that question is, look, it's on that list, isn't it? Square root of 64. Can I answer that question? What number could I square and get 64 as the answer? What's the answer? That's what 8 squared is, isn't it? You notice that once I answer the question, what happens to the square root sign? It goes away. I've done what it's asking me to do. But then we get to one like this, square root of 20. Can I answer that question? It's not in this list, is it? 20 is right here, isn't it? And everybody just watch. Everybody just watch. Don't write down. So you say, well, I can't answer that. I just have to leave a square root of 20. Well, the problem is that's a non-terminating, non-repeating, or a non-terminating, I'm sorry, that's a non-terminating, non-repeating decimal. In other words, it doesn't repeat the same pattern, and it never stops. We want the most accurate way we can express this is with the square root sign. But what we want to do, and what we're learning how to do in this section, is something you should have done in algebra, but we want to simplify this as much as you can. I understand some of you have been taught to do prime factorization. Some of you have been taught that way. I wanted you to do it this way for this. Once you do it for tests, whichever way is more comfortable, I don't care. But for now, I want you to understand the concept of what we're doing. What we're going to do, and it comes with this, is we're going to use this. You guys know square root of AB is the same thing as saying square root of A times square root of b. So when I multiply two things, what can I do? I can what? Split them into two separate square roots, can I? Everything we're going to do on simplifying these is based on this. Okay? So what I'm going to do is I'm going to ask myself, what is the largest perfect square that's a factor of 20? So I look over here to my list. It's got to be a number less than it that's a factor of it, right? Will 16 go into 20 evenly? Will 9? Will 4? Huh? So I could write this as square root of 4 times square root of what? Why did I do that? What advantage do I have? What good does that do for me? Can anybody answer me? Right now, I had nothing under the square root sign. I could answer the question, right? Now look over here. Do I have a square root that I can answer the question now? Which one? Square root of? I can answer this question. The answer to that question is what? However, can I answer that one? What's the largest perfect square? It's a factor of 5. So that's, I know it's simplified. I can't answer that question. So how I write this is 2 square roots of. There is your answer. I want you guys to work down, not to the side. But that's what we're going to do. Not every number can be simplified. For instance, square root of, we'll go with square root of 30. What is the largest perfect square? That's a factor of 30. So what do I need to go over here? Look at my numbers. 30's right here, isn't it? Will 25 go into 30 evenly? Will 16? Will 9? Will 4? No, it won't. Will 1? What's the largest perfect square? It's a factor of it. So guess what? It's simplified. That's as much as you can simplify it right there. So when you're doing these, you'll just write down square root of 30 and circle it, because that's your answer. What about this one? You know what'll happen lots of times, guys? You get so caught up on simplifying this stuff, you'll forget that, hey, check and make sure that's a perfect square before you start simplifying it down. Okay? Now, square root of 324. How about this one? You need to look on your list, don't you? How about this? Square root of 156. And I am going to work down now. And I'll record this as I'll upload so you can write it down in just a second. In fact, I'll screenshot this whole page if you want me to. Okay? So just listen. Don't worry about writing down as much. Well, square root of 156. Is that on my list? No, it's not. Here's the deal, guys. Use your noggin here for a second. I got to find the largest perfect square that's a factor of 156. Stop writing and pay attention, guys. What is always the largest number besides itself that will go into a number? What of that number? Answer this. What's the largest number that would divide into 10 evenly besides 10? How about 5? What's the largest number that will divide into 20 evenly that's besides 20? 10. What's the largest number that will divide into 50 evenly besides 50? What's the largest number that will divide into 80 evenly besides 80? What are you doing each time? The biggest number besides itself that will always go into a number is half of it, right? So when I'm looking at numbers and I'm saying I need to find the largest perfect square that's a factor of this, should I start at 156 and down, or should I start at half of 156? Half, because if it's more than half of it, it can't divide into it. It's impossible. So what's half of 156? 78? So actually, you can start right here. Now, I don't expect you to know the factors in 156 off the top of your head. So go 156 and now divided by 64. Do you get a decimal? Okay, 156 divided by 49, do you get a decimal? 156 divided by 36, do you get a decimal? 156 divided by 16, do you get a decimal? 156 divided by 9, do you get a decimal? 156 divided by 4, do you get a decimal? So what does this break down to? Always put first, so you know square root of 4 is your biggest, largest perfect square, right? That was your big one, right? So always start with this. You can break this up into the square root of 4 times what? Well, you got to look on your calculator. It's what did, what was left when you divided it? Huh?
39.
So this is square root of 4 times what? Square root of 39. What is the square root of 4? Is a large perfect square. It's a factor of 39, 1. It is. So you know you've simplified it. Let's go to the copies we just made, which you all should have in your desk. Simplifying radicals. I want everybody on their page to come over here, write PS, put a line under it. I want every perfect square written down there. You can all do that right now. Then when you're done, turn this over and write it on the other side. Off to the side, out of the way. Just in case you're wondering, if you decide not to do this, you don't write the perfect squares on your paper, you'll get half taken off. I want it on both sides. So please write the perfect squares down.
What about the packet that we got? Do we have to do it?
You have to do that too, but right now I want you to write it on this paper. Guys, have you got all the perfect squares written down off to the side? Your paper should look like this. And then when you turn to the back on the right side again, it should look like, you know, have that there as well. If I make you write these down over and over again, guess what? You start remembering them. Those are the only numbers you're worried about dividing into. Seeing if they'll go into the numbers. Basically, you're trying to get as much out from under the square root as you can. That's what simplifying a square root is. And by the way, I know your calculators can do it for you. Some of them can. So check your work with it. If you don't write down the second step doing this, you might as well not have done it. You will not get credit for it. You will get a 0. On this sheet of paper. Because I'm not trying to teach you how to punch numbers into a calculator. I'm trying to teach you to understand the concept of simplifying a square root. Now, if you had did it by the prime factorization method she was teaching the first worksheet, I'm okay with that. That's work shown on the first worksheet. This is why we're kind of starting over again and getting a second worksheet. Because I want to make sure you do it this way. I'm not going to hold it against people. Because she taught it the way she knew how to, because the videos have problems, and that's fine. I have no problem with that at all. But what I want you guys to understand is the concept of a perfect square. That perfect squares are the only numbers that you can simplify a square root and they come out evenly. That's something you need to know for in the future. You need to recognize, a light bulb needs to pop up when you have something like number, well, so far we don't have any of them. Let's look on the back side. Doesn't look like we have any of them. Okay. None of these are perfect squares, I don't think. All right, let's look at number 1. Square root of 75. Is that a perfect square? Okay. What's the largest perfect square that'll go into it? Well, instead of starting at 64, what should we start at? Half of what? 75. What's half of 75? 37.5. So we'd start at what? 36. Will 36 go into it evenly? Will 25 go into it evenly? Right now, that's yes. So this is square root of 25. Put your perfect square out first, times what? Square root of what? 3. I expect that is the important step. That's the one I have to see every single time with the square roots and everything. Does everyone understand that? I don't see that step, you might as well not have done it. If you go here and then all I see, what is the square root of 25? If all I see is 5 square roots of 3 under that, you didn't do it. If that's all I see. If I don't see that step, you will get a 0. I mean, let's put it this way. That problem, you get no credit for. If you just screwed up and only did it on 2 problems, I'm not going to give you a 0 for the whole thing, obviously. Okay? Because I know you can put it in your calculator, and plus, what the skill I'm wanting you to learn is to understand that we're just breaking this up into a product of the largest perfect square, another one. Now, now I want you to watch. On number 2, I'm going to make a common mistake here, okay, guys? So just watch. Okay, and like I said, I'll screenshot all this and upload it to Canvas. So no writing. Watch up here. This is a common mistake. However, it can be recovered from. Why do you think that's a common mistake? Well, you looked at this, you saw 32, and you thought of the number 4. That's a perfect square, right? Hey, that'll go into it, right? It will. So this will break up into 2 square roots of 8. The problem is, yes, you have simplified it, but not completely simplified it. Because the 8 can be simplified. When you get to this part, just keep going. 2 times. What is this? What large perfect square can go into 8? It's the square root of 4 times square root of 2, right? What is the square root of 4? So this becomes 2 times 2 times square root of 2. Now, I can't multiply. Remember, things outside the square root can't multiply with things inside. Only things outside. But since these both are out here, what's 2 times 2? You can still get to the right answer, and this would be fine if you make that mistake. If you look and say, hey, wait a second, that's not factored, and you keep going.
Wouldn't that be the square root of, like, 2 times square root?
Exactly. If you went by the list and went through the method and said, okay, what's the largest perfect square? It's a factor of 32. You started at half of it. Half of it actually is what?
16.
So you'd break it into square root of 16 times square root of what? Which is what? It's handy to use this method when you have reasonable numbers. I will admit other methods are better sometimes when you have very large numbers. First admit that. Okay? In fact, when we have big numbers, I'll add them up and see if 4 will go into it. Add the digits together and see if 4 will go into it. If it will, then I just, on a big number, I just make, try to make it smaller right then. Start something easier to deal with. Good example of that. Turn on to the back. Let's look at number 29. That's a big number, isn't it? 1 and 5 is 6, 13, 16. There's a good chance 4 will go into that, wasn't it? Square root of 4 times square root of what? 1573 divided by 4. What do you get? That one won't work. Okay. 4 won't go into it. Well, let's start with half of it. What's half of it? 786.5. Let's see. 2 won't go into it. Let's see if 9 will go into it. Let's see if 16 will go into it. Let's try 25. Obviously won't. Let's try 36. Let's try 48. Or no, not 48. 49. Okay. Let's try, what's next? 50, or, 64? I don't think there's a 4 that has a 3 at the end, is there? Let's try 81. Huh? Huh? 121 does? So square root of 121 times square root of what? $13? See, sometimes you just gotta keep guessing and testing. Sometimes you just start at the bottom and go up, too. Sometimes it's not. Well, 11 square root of 13. That's it, isn't it? Because square root of 121 is what? 11 square root of 13. Well, that's obviously simplified, isn't it? The large perfect square factor, it's 1. See, in my opinion, just finding a number that'll go into that, 3 won't. Because you know, actually you add the digits together, you know 3 can go into it. Now let's go up here to 704. See if 4 will go into 704, will it? So maybe we see if we can get it a little smaller. Okay, so square root of 4 times square root of what? 176? So your true square roots of what? 176? Now you're with a much more manageable number. Now we just got to check and make sure that's simplified all the way. Okay? Half of 176 is what? 83? Or no, 88? 88? I bet you, well, see, well, if you want to, see if 4 will go into it again. Will it? So 2 times square root of 44. Well, I think we know square root of 44 is 4 times 11, right? Right? So now we've got 2 times 2 times 2, square root of 11, which is what? 2 times 2 is 4 times 2 is. So on bigger numbers, sometimes it's easier just to do that, isn't it? Just keep it straight. Show your work, keep it straight. Everybody write that down. These two down so I don't have to, because I won't screenshot just this back. One you'll see a lot, square root of 63. What's the large perfect square? It's a factor of it. That, you know, some of these you ought to be able to look at and get pretty fast without using the list. Huh? 9. Square root of 9 times square root of 7. Obviously, square root of 7 is going to be reduced, isn't it? That's a prime number. So what is the square root of 9? I think this is the best way to do some of your smaller numbers. I do think the prime factorization, because in essence that's kind of what I'm doing here, isn't it? With some of the bigger numbers when I'm breaking it up. But I think this method is very, very good and important for doing the ones you're going to deal with more, which are probably more reasonable numbers, is what you'll deal with most of the time. Okay? Because, you know, what you'll do is you'll have, like, square root of 128. Okay? As odd as that number looks, it actually reduces to a very reasonable square root. Because guess what? That's square root of 64 times square root of 2. Which is what? 8 square roots of 2. And what we're going to do next is we'll realize that, hey, square root of 32. If you had square root of 128 plus square root of 32, what's going to happen here? Square root, this is going to be square root of 16 times square root of 2, correct? I started out with problems that were not like terms, but then when I simplify it, what do they end up being? They end up being like terms. And this simplifies 12 square roots of 2. So that's what we're going to do next.
Do my tags?
I haven't checked them all yet.
I'm throwing.
You are
Yeah, I sent you
in the
that.
pen?
Yeah. Wait.
I mean in the,
Showcase.
okay.
Yeah.
All right. See you guys. See you. All right. Let's get to work on this worksheet. These two worksheets are due tomorrow by the end of the hour. Darius.